Hope you all had breakfast. Breakfast ಆಗಿದೆ ಅನ್ಕೋತೀನಿ. ನಾನು ಮಾಡಿಲ್ಲ ಏನು ಬಟ್ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಏನು ಮಾಡೋಕ್ಕಾಗುತ್ತಾ ಇಲ್ಲಾಂದ್ರೆ ಪ್ರಿನ್ಸಿಪಲ್ ಸರ್ ರೌಂಡಿಂಗ್ ಬರ್ತಾರೆ. Okay, we'll continue the yesterday's class only. In the last class, we have seen the what is the parallel programming. Okay, we already completed the parallel programming in the hardware. Today, even we have completed seen the how the parallel computing. Okay, that's nothing but the parallel computing in the program. Also, we have seen in the last class. Okay, until the execution of the first thread, it will not go to the second thread. Okay, and we have seen the shared memory programs also. In that we have seen we have shared memory programs and also distributed memory programs. Okay, in the earlier classes we have seen the shared memory memories something. Okay, shared memory, distributed memory, like this in the hardware. But similarly in the programming side also we have the two types. That's nothing but the shared memory programming and also distributed memory programming. Okay, in the shared memory program we have seen the how the if any variable is private, that also accessible. Okay, that's not accessible to the others. Okay, that's to be accessed by the only single core. Okay, that's to be shared one. Okay, the private variable, if it's available to the one core, that's to be accessed to the only one core, that is not access to the another core. Also the communication is here the implicit rather than the explicitly will not provide the any communication. Okay, ಅಂದರೆ ನಾನು ಇಲ್ಲಿ ಕಮ್ಯುನಿಕೇಷನ್ ಸಲುವಾಗಿ ಒಂದು ಥ್ರೆಡ್ ಟು ಅನದರ್ ಥ್ರೆಡ್ ಕಮ್ಯುನಿಕೇಷನ್ ಮಾಡಬೇಕಾದ್ರೆ ನಾನು ಪ್ರೈವೇಟ್ ಆಗಿ ಇಟ್ಟಿರ್ತೀನಿ, ಅದನ್ನು ಆ ವೇರಿಯಬಲ್ ಮುಖಾಂತರ ಎಕ್ಸೆಸ್ ಮಾಡ್ಬೋದು. ನಾನು ಪಬ್ಲಿಕ್ ಆಗಿ ಯಾವುದು ಕೊಡಲ್ಲ ಇಲ್ಲಿ. ಓಕೆ, ಇಫ್ ಇಟ್ ಇಸ್ ಎ ಪ್ರೈವೇಟ್ ದಟ್ ಟು ಬಿ ಎಕ್ಸೆಸ್ ಟು ದ ಪರ್ಟಿಕ್ಯುಲರ್ ಕೋರ್ ಓನ್ಲಿ, ಅದು ಅಂತ ಹೇಳ್ತಿದ್ದಾನೆ. ಬಟ್ ಈವನ್ ವಿ ಆರ್ ಸೀನ್ ದ ಡೈನಮಿಕ್ ಅಂಡ್ ಸ್ಟ್ಯಾಟಿಕ್ ಥ್ರೆಡ್ಸ್ ಆಲ್ಸೋ. ವಾಟ್ ಇಸ್ ದ ವಾಟ್ ಆರ್ ದ ಏನಮ್ಮ ನಗ್ತಿದ್ಯಾ? Okay, in many environments we have seen the shared memory systems as the dynamic threads. Okay, in the many, okay, we have seen the master thread. Okay, if the until the master thread request, that will not access the another thread also. Okay, even the this shared memory programming, it's like a fork. Okay, single program is there, it can have the multiple threads over that one. Okay, multiple threads over that. In even we have seen the so many things like the non-determination. Okay, non-determinates means in the similarly we have seen the non-bit determinants in the CMD. Today we'll see the non-determination in the MIMD. That's nothing but the multiple threads. How the multiple threads will be executing one by one, but there will be slight difference between the one thread execution. That is what we call the time elapses. Okay, one thread execution it will take the some other time, and even the second thread will take the other period of times. Okay, that we call as the multiple threads can be executed independently on the independent OSS. But thing is that it's a there is a difference. Okay, there is a difference between the run one thread run to another thread. Okay, that we call as the we can consider the we can do the the time elapses. Time for the thread one will be ranked with the rank 0. So time elapses, time for taken for the execution of the thread 0, it is to be rank 0, it is to be named as the rank 0. And also thread for the thread 1 execution purpose will can give the name as the rank 2. Okay, rank 1. Okay, it's nothing but the rank 0 and rank 1. For the execution of the rank 1 for the thread 1. Okay, please yeah, so one check from the okay. Okay, we'll consider the first, let us consider the non-determination. In MIMD. Okay, MIMD. Okay, if you consider the two threads are there. One thread is what the thread 0. Another thread is the 1. Okay, these two threads will be take the different times for the execution. Okay, even the this can be ranked with the rank 0. This to be ranked with the given the rank name as the rank 1. Okay, these two threads will take the different times for the execution purpose. Okay, and with the if you have the small pseudo code is there. Okay, if you have the code as the printf printf, okay, thread percentage d is to be my x has come in equals to percentage d slash n rank, okay, even. Okay, this is the pseudo code. Okay, this is the some code is there. Okay, okay, this part of code is to be execution. Okay, here the how many threads are there? Two threads are there. Okay, thread 0 will take the some period of time, and also thread 2 also it will take the execution of period of time different. Okay, how this one can be seen is the printf is the one of the statement is here. Okay, by this execution of this statement we can get the different time ellipses between the thread 0 to thread 1. 7 sum 7 sum 1360 20 20. Okay, then the execution can be written as the, then the output could be here thread 0 x, thread 1 my x, and also it could be here thread 1 my x. Okay, here the two threads are there, thread 0 and thread 1. Okay, then we have the one variable that's we calls the my x variable. Okay, my x variable, it can have the more values here. My x can have the value as the first initially it would be at here the 7, and also it could be here the my x for thread 1 is thread 0 is initialized with the 7, and it would be here the 19. Okay, then the if the threads are having the values, my x has the variable. Okay, that's the variable can have the two values, that's 7 and 19. Yes sir, 7 and 19. Okay, while taking these two values, thread 0, thread 1 will execute one by one. Okay, for the order can be changed here. Okay, the order can be inter exchanged. Okay, inter exchanged. Here the order can be inter-exchanged from the, it can execute the from the thread 0 next to thread 1. Even it can also execute the thread 1 first, then the thread 0 also. It means here the non-determinism is happening here. It means what here the, it could be sometimes it could be here the working here the wrong way. Okay, working will be wrong here. Even the output of the one thread could be taken broken up into the two different time elapses also, because the it could be if it's running first time. Okay, if it's run in the first, then it will take the different time. If it's run in the second time, it will take the another time. It's a time elapses between the one thread to another thread is can be different here, because of the their order of execution would be here the changing here. Because if the my thread 1 0 is executing first, it will take the other time, and even the my thread is executing the different times, that's the second time, that will take the other time also. That means here the thread 0 is executing first, it will take the, and what's time, what's your problem problem ಡಿಸ್ಟರ್ಬ್ ಮಾಡ್ತಿದ್ರಾ ಫ್ಯಾನ್ ಇಲ್ಲ. okay, because of the threads executing independently from the one thread to another thread also, even though it will takes the one time to another time, we can predict the value here if it is executing the serially, if it is executing serially. But if it is taking the order in which the, even I can also take the thread 0, thread 1, thread 2, thread 3, it will be, if it's in serially it's executing, that in the we can also predict the time analysis gap between the one thread to another thread. If it's executing the if it's not executing the serially, if it is executing randomly, then the time cannot be predicted here. This is also one of the non-determinism, okay, this is the one of the non-determinism. The order is the, if the order of execution, okay, if the threads are executing in the order way, then the time elapses, okay, the time taken for the one thread to another thread execution to be, can be predicted here, okay, we can also predict the time. But if the order of threads are executing in different, okay, in order, okay, it's not executing the in order, then the time elapses, so time taken for the thread 1 execution to the another thread 6 also, it will be different here, okay. That's nothing but here the non-determinism is happening here, okay, non-determinism is happening here. Suppose in such a situation, if I consider the int value means what here, the, if I am executing the int, okay, if I am executing the int value, having the value as shared value as the my x, my x is the one of the variable, okay, it will takes the time to execute, okay, in different, okay. If I am executing the my x, my x variable for the, with the help of the, in the variable having the values as the int variables 0, 1, 2, 3, 4, 5, like this, okay. If it is not having any pointed values, means what, floating values, then it can be considered as the int values to be considered to be executed in the properly, okay, properly, okay. Then the, I can also execute the this program as the my my value, compute value. This is the one of the pseudo code. Okay, if you are executing the, if you are exchanging the value from the my value to the x, okay, if you are sending the values of the my value to be having the x values, that is to be taken to be one pseudo code is there with the help of the my value variable as the compute the value my rank. Okay, that's nothing but the other my value will be, that's the variable what we are sending, that's the int variable only with the, in the form of the my variable, my value, that is to be added to the, considered to be taken to be which variable, x variable, okay, x, okay. We can recall in the addition, okay, we can recall in the addition of the some elements, okay, some values, okay, which are stored in the registers, okay. First you have to be fetch from the values from the main memory to the registers. If you want to add the two elements, okay, if you want to add the two data from the registers, okay, in the registers, then I have to consider, I have to fetch from the, I have to read from the elements, okay, data from the main memory to what is the registers, main memory in the register read ಮಾಡಬೇಕಾಗುತ್ತೆ. Next, after reading the, after the fetching the value from the main memory to the registers, then I'll make the addition there, okay. If the two elements, two values data here the 5 plus plus, then I have to be initialized first, earlierly 0 0, then I have to fetch the those two values from the main memory to the register, main memory in the register ka call ಮಾಡ್ಕೋತೀವಿ, read ಮಾಡ್ಕೋತೀವಿ. Then after the operation, we are, what we are doing the operation is a addition operation, addition, okay. After the performing the addition operation, then I have to store back the result where in the main memory only, main memory only. That's nothing but we are doing the first read or fetch operation, then the operation, then the write back to the value here, write back the value here, okay. That's nothing but in the, in order to recover such a situation, we have the main memory to the registers and also register to main memory also moving, okay. That's nothing but here the, we have the some order of execution. If I have the core 0 execution processor is different, if I, then the core 1 will take the with the step increment of the core 0, ಕೋರ್ 0 ಸ್ಟೆಪ್ಸ್ ಅಲ್ಲಿ ಏನೇನಿರುತ್ತೆ 5 ಪ್ರೊಸೀಜರ್ 5 ಸ್ಟೆಪ್ಸ್ ಇದ್ರೆ ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಗೋಯಿಂಗ್ ಟು ಫಾರ್ ದಿ core 1, then it is to be added plus 1. Okay, that's nothing but the, if I am fetching here, then there will be a decoding is there. Okay, if I am okay, that's the nothing but the parallelism we have seen in pipelining, we have seen in the earlier classes. Fetch ಆಗುತ್ತಾ, decode ಆಗುತ್ತಾ, ಮತ್ತೆ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗುತ್ತೆ. ದ ಸೇಮ್ ಪೀರಿಯಡ್ ಆಫ್ ಟೈಮ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗ ಡಿಕೋಡ್. ಓಕೆ, ದಟ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ಡಿಕೋಡ್ ಆಗೋ ಟೈಮ್ನಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಫೆಚ್ ಆಗುತ್ತೆ. ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗೋ ಟೈಮಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಡಿಕೋಡ್ ಆಗ್ತಿರ್ತದೆ. ದಟ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ವಿ ಆರ್ ಡೂಯಿಂಗ್ ಕೋರ್ 0, ಕೋರ್ 1 ಆರ್ LFCing. ಓಕೆ, ಇಟ್ ವಿಲ್ ಟೇಕ್ ದ ಫ್ಯೂ ಸೆಕೆಂಡ್ಸ್ ಆಫ್ LFCing. ಓಕೆ, ಒನ್ ಕೋರ್ 0 ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗಿ ಕೋರ್ 1 ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗಬೇಕಾದ್ರೆ ಸಮ್ ಟೈಮ್ ಆಫ್ ಗ್ಯಾಪ್ ಇಸ್ ಬಿ wasting here. Okay, that's nothing but we are have the some order here. Okay, some order here, how the course will be executing here. Okay, first one is the read operation. First I have to be read or fetch the data from the main memory to where in the main memory to main memory to register. Okay, after the taking the values, I have to perform the sum operation. Okay, if you want to add the addition operation, if you want to do the sum operation, addition or subtraction, whatever it may be, after the performing the addition operation, then the result should to be stored back to register to main memory only, main memory. Okay, this is to be vary from one core to the another core. Okay, that is to be, I can see this time core 0, core 1. Okay, core 1. Okay, time. Okay, in the time of 0, 1, 2, 3, 4, 5. Okay, in the period of time we'll be doing the different operations here. Okay, in the period of time we are doing the different operations for the core 1. Core 0, if I consider the core 0, finish the assignment to the, okay, assignment to, okay, I'll be taking, okay, while assigning, okay, I have to assign the values to the variables here. My here the one variable is that is nothing but the my value is the one of the variable which will be having the, we are assigning the some values to the in the period of time 0, in the period of time 0. Okay, in the after that in the period of time 0 we are what we are doing, assigning the values to the variable. Okay, next in the period of 1, okay, in the period of time 1, load x equals to 0 into the register. Okay, even we will be first okay, let me write first. Okay, look at here. Okay, in the initial, in the period of 0, in the period of 0, finish the as the assignment of the value, m value initialize ಮಾಡಬೇಕು. Okay, that the load the, okay, whatever we are assigning the value here, variable here, the having the variable as the x equals to 0, we are initializing it, means we are loading the values x as the 0. Then the load my value to the 7. Okay, earlier it was what value, 0. Now it is to be assigned to with the 7. Okay, 7 which will be stored where in the register, in the register. Okay, next values to be added here, the what here, the that is to be 7 to be assigned to where in the x. Earlier it was y, x is having what value here, 0. Now it is to be considered, okay, given as the x, it will becomes now it's 7 here, 7. Then the store x equals to 7. Store x equals to 7 and the start other work means what? We can go for the other initializing of the other variable also, other value also. First finish the assigning of the my value as the something that is to be x equals to 0. X equals to 0 in the period of 0 and in the period of 1. Okay, and then the load the my value as the x equals to my value is to be 7. Okay, my value is this 7 here, my value is here and x is there. Okay, earlier my value is not here to any having a value, but the my value is having what value here 7. Okay, that 7 is to be considered here as the my value is to be 7 itself, because the in not will be assigning that value to be to the where which value x. Now the x will becomes what here now is it's a 7 to be stored in the main memory, back to the main memory, that is to be for the core 0. Similarly I will be writing the same thing here in the call to in the core also in call. Okay, another variable I am using here compute value. Okay, compute value, another variable compute value I am using here. I use here which variable here, my value. Okay, now it's the here the I am using the compute value. Okay, finish assignment. Okay, one step ahead here. Okay, it's whatever we are doing in the first step, that is to be okay, one step to the earlier one. Okay, we are moving. Okay, first earlier it was we are assigning here, but now we are in the second period of time we are assigning the values here. We are the assigning the values as the my assignment to the my value. Okay, load x equals to 0 in the register, same thing. Okay, earlier it was we are loaded in the period of 1, but in the for core 1 we are doing the loading operation here, the core 1 in the period of time 2 here, time 2 here, and also add. Okay, load my value equals to 19. Okay, 19. Okay, my load equals to my value equals to load 19. Earlier it was how much here, sir? 7 here. My again I am taking the my values to be 19 here. Okay, then the add the add my value, my value to x. Earlier x is having what value here? 7, but the 7 plus 19 is we are adding here. Then the result is to be stored back here. Store the x equals to 19, then also store the value of the addition of the 19 plus 7 is how much? 25 is to be stored back to in the x value only, in the x itself. Okay, earlier it was having the value as the x as the 7, next value is what here the 19, then after the addition the x value becomes what here the 25 here. Means what here the we are doing the three operations, read, fetching, and also addition operation. Then also we are right back, we are giving the result back to the main memory only. Okay, that's in the which will be vary from the one core to the another core. Okay, one core to the another core. Okay, in such a situation the core, okay, in such a situation the execution of the thread 0 and thread 2 will be racing in each other. Okay, until the execution of the thread 0, thread 1 has to be stopped there. Okay, that's nothing but the racing here, one thread. Okay, and means what here, the thread 1 has to be executed only when the thread 0 is execution. That's nothing but here the race between the thread 0 and thread 1 is happening over here. But this condition we call as the race condition. But we are the in this thread 1 is wait, we have to wait, which has to be wait for the until the execution of the thread 0. But the race condition is false here, because of the in order to overcome such a outcome we will go with the that is nothing but the x plus equals to my value here. Means we are assigning the value here, such a situation, in such a gap. Okay, whatever we are doing the assigning the value from the x to the earlier 7 to the 19, which will be called as the atomic. Okay, in such a word we call the atomic. In order to get the atomic condition, will have to be assigned the x value. It was earlier 7, now it is to be assigned to 19. 7 ಇದ್ದದ್ದು 19 ಆಗೋ ಚಾನ್ಸ್ ಚೇಂಜ್ ಮಾಡಬೇಕಾದ್ರೆ that is to be gap. Okay, that is the assigning of the earlier value to the 7 to 19, the x to the x plus 1 value something, that is to be called, we call the atomic one. Okay, we are overwriting that x value, which is to be called as the atomic condition. We call it the atomic condition. Okay, there are two conditions. One is called the race condition, another one is the atomic condition. Here atomic condition is nothing but the will be getting the value to be incorrected value, which is to be overwritten with the new value, that is we call as the atomic condition. Okay, okay, in arts, okay, one more is there. First one is the race condition, another one is the atomic condition, third one is the critical section. Okay, critical condition, critical section is nothing but the block of code. Okay, the block of code which is to be executed, that is to be readed, okay, by only one thread. Okay, only one thread. ಈಗ ಏನಾಗುತ್ತೆ ಕ್ರಿಟಿಕಲ್ ಸೆಕ್ಷನ್ ಕ್ರಿಟಿಕಲ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಬ್ಲಾಕ್ ಆಫ್ ಕೋಡ್ ಇರುತ್ತೆ, ಯಾವುದೋ ಒಂದು ಬ್ಲಾಕ್ ಆಫ್ ಕೋಡ್, ದಟ್ ಬ್ಲಾಕ್ ಆಫ್ ಕೋಡ್ ವಿಲ್ ಬಿ ಎಕ್ಸಿಕ್ಯೂಟೆಡ್ ಬೈ ದಿ first thread only, first thread, then the that block of code will be blocked to the next thread. Such a situation we call as the critical section or critical condition. Okay, it is to be waited for the next execution. One thread execute ಮಾಡ್ಬೇಕಾದ್ರೆ block of code execute ಮಾಡ್ಬೇಕಾದ್ರೆ that is to be wait for the another code, in another thread wait ಮಾಡ್ಬೇಕಾಗುತ್ತೆ. Such a condition we call as the block condition. Okay, okay, sorry, critical section. Okay, critical condition. Okay, critical condition, the most commonly used as such a mechanism to ensure the mutual exclusion. Okay, we will be we are exchanging the values from the x to the 7 and even x is to be 19. Such a situation we call as the mutual exclusion. Okay, sometimes we call as the mutex also, sometimes we call as the mutex also, and also we call as the simply lock, because of the to have the another value. X is to be having the two values here, one is to be 7, another is to be 19. So in order to get the value of the second value 19, that is to be what here, the simply lock, first value has to be locked here, first value has to be locked here. So that we call this condition as the simply lock or mutex or lock condition also, we call it the lock condition also. Okay, in such a situation, in the critical section, it should be relinquishment. Andre, we should have to avoid the such a situation, such a condition. We can get the value called, we can get the another condition called the obtain condition. Okay, in order to overcome such a condition, we will have go for the obtain condition. Mutex is there, obtain condition. Okay, so in order to overcome such all the things, we'll have the obtain condition. Okay, obtain condition is nothing but we have the one value here. A complete theory another. Okay, here the piece of code is there. This one is the, okay, this code executes the particular, we can say it's a lock operation, and also we can have the rank operations here. Okay, first initially the my value is having the compute the one method compute value that's to be ranked on the based on the what rank thread 0 and thread 1. Okay, that is to be locked here because of the add the my lock here. Okay, in order to execute the only particular thread here, only particular thread. Okay, instead of execution, all the threads will be in the race. Thread 0, thread 1, thread 2, thread 3, like this. Okay, all threads to be in the race. In order to avoid the such a situation, race condition, we have the lock operation, a lock here. Okay, lock condition here. So if I use the lock operation, that is to be a lock in the particular thread value here. Okay, then the that particular next the unlock that particular after the execution of the statement here, the x equals to my value, then only the unlock that particular my lock here. Okay, that's nothing but we are locking the period of locking the part of the code here, because in order to get the race, in order to avoid the race condition here, race condition. Okay, thread 0, thread 1, thread 3, thread 4, like this, they are all in the race condition. Okay, in order to work only with the what here the particular thread, then we'll put the lock condition here. The code for the putting the lock condition here. So we have the value here, the my value, it is to be initialized to be the compute value my rank, and also lock condition we are putting. Okay, and this, okay, after the execution of this one, it is to be executed. Okay, until the execution of this x plus equals to my value, that the unlock will not execute here. Okay, unlock will not execute, means it here the unlocking the particular piece of code or particular thread in order to get the execution of the particular another thread here. Take the some notes. Take the heading as the shared memory programs. Shared memory programs. Shared memory programs.